Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.2, Problem 6. This is Section 15.2. It's problem number 6. We want to find the integral of the cube root of 7x plus 3 dx. What makes this tough is you have a cube root of the 7x plus something. Without the plus 3, I could do this problem without the substitution method. But because of that plus 3 in there, I have to rename what's under the root as a new variable, solve the integral, and then put the x's back. So the first thing I'm going to do is choose a value for u. And the only one that really fits is stuff under the root. I don't have parentheses, I don't have a denominator, I don't have an e. So the value for u will be 7x plus 3. So that's the first step in the process. The next thing we do is find the derivative of u, which we label du for derivative of u. And the 7x has a derivative of just 7. When you have an x to the first power, the derivative is the value in front of the x, in this case positive 7. The 3 on the end has no x with it, so its derivative is 0. So I really have 7 plus 0, just 7. And you put dx on the end for derivative with respect to x. So now what I'd like to do is, now that I have the u and the du, is rewrite the problem in terms of my new variable. So I'm going to have the integral of cube root of u instead of cube root of 7x plus 3. Now the dx on the end, I don't really have a perfect match for this. I have 7 dx. I know what 7 dx is equal to. I don't want 7 dx. I want just dx. I need to get rid of the 7. So I'll just adjust it a little bit. It's an equation. I can do anything I want as long as I do the same thing on both sides. So on both sides, I'm going to multiply times 1 over 7. It's totally legal. So on the left side, 1 over 7 times du is 1/7 du. And on the right, 7x dx times 1 over 7, the 7's cancel. So I have dx. So now I need to replace dx. I know it's exactly equal to 1/7 du. Now I've written the original problem in terms of a new variable that I can solve the integral for. It still looks kind of messy here, so let me do two things. First, that 1/7, I can move that in front of the integral symbol. Again, I can do that because it has no variable with it. It's just a number, or what they would call a constant. So I'm going to have 1/7 times the integral of, not cube root of u, I don't want it in that form. I want to write that cube root as u to the 1/3 power. I want an exponent. And then, of course, the du at the end. Now I can solve the integral. The 1/7 that's in front, let's just leave it in front. It's going to be times, my exponent is 1/3, so I'm going to have 1 over the old exponent of 1/3 plus 1, when I do the integral, u to the old exponent of 1/3 plus 1. And don't forget there's a plus a constant. And again, that is the answer, but I really need to clean up the fractions out in front. So the 1/7 that it starts with, let's leave it, 1/7 times 1 over 1/3 plus 1 is 4/3. And if you don't see it easily, think of the plus 1 as 3/3. 3/3 is still a 1, but now you have a common denominator of 3. You add the numerators 1 plus 3 more. There's the 4 for 4/3. U to the same process, 1/3 plus 1, you can write out the same way. It's 4/3 and plus a constant. So that's better, but still not good enough. The 1 over 4/3, that can be simplified to just 3/4. Again, I have a fraction in the denominator here. I simplify that by inverting the fraction, becomes 3 over 4 times the top, so times 1. 3/4 times 1 just stays 3/4. So add a 1/7 in front, it'll stay in front. As I simplify the 1 over 4/3, it simplifies again to 3/4 by inverting the 4/3 and multiplying it times the one that was in the numerator. That's 3/4. U to the, here it stays 4/3. It wasn't in the denominator or anything, no need to invert it. It just stays the way it was. And you have plus a constant. Now to clean it up a little bit further, I have two fractions in front that need to be multiplied, which is easy enough to do. To multiply, you don't need common denominators or anything. Just top times top, 1 times 3 is 3. Bottom times bottom, 7 times 4 is 28. and then u to the 4/3 plus a constant. Now that I have it simplified, I can go ahead and write the answer in terms of the original variable, which was x. So the 3/28 in front I will leave in front. But instead of u to the 4/3, I'm going to write 7x plus 3 to the 4/3 because that is what u is equal to. 7x plus 3 to the 4/3. And at the end of my answer, of course, there is a plus c.